Okay, so before we start, I would like to ask your permission for the recording of this lecture. And after this, we will have to publish this lecture on the web, on the YouTube. And just to say yes or anything, you could comment on the screen or in your microphone. Okay, so we will start. Thank you. Okay, so we will start now our topic on IP addressing. So what is an IP? So IP is an Internet Protocol. It came from your TCP IP term. So TCP or IP, we have this term, Transport Control Protocol, and we was able to discuss it last time. So now, IP address or IP addressing start with version 4. This is a 32-bit number divided into 4-bit values. We call it octets. So each octets can have value from 0 to 255. So in the previous test in the game, when you will see more than the value, it means that that is not a valid IP address because we will have only values from 0 to 255. So why is it that we do not have 256? So we have 256, but it is not under the 8-bit octet. So that would be on the 9th. So because we start our count in 0, and this is your 256 character from your decimal value. So remember, all first count always in binary and decimal in computer will start at 0. And IP addresses are written in a dot decimal notation. This format consists of 4 decimal numbers, and each range to 0 to 255. And this is separated by a period. So as an example, so we have 10.255.0.0, and take note, our first octet is 10, second octet is your 255, and third is your 0, and your fourth is your 100. Now, in this lecture, you will try to identify what is the network ID and what is the host ID. So this is very important in order for you to be able to check which would be the network ID, and also with this you could identify the subnet mask. Now we will have the number of contiguous series of binary digits 1 and followed by a contiguous series of zeros. Take note, we don't have a subnet mask like 1010101, but we have contiguous series of ones, so meaning all should be in the 255. So what is the value of 255? By the way, 255, if you're going to convert 255 into binary, is equals to 1, 1, 1, 1, and this is your binary value. So how do you know that this is your binary value? So you have 1, 2, 4, 8, 16, 32, 64, 128, and you have 255. So the start will count on this side from this point up to this point. So this is your least significant bit, and this is your most significant bit. That is on the right side, and this on the that is on the left on your side, and in the right of the binary value. Now, later we will try to check. So this one, these are example of your subnet mask. So this subnet mask is another 32-bit dotted decimal number that is consisting of your contiguous series of ones and zeros. Okay, so in binary, the subnet mask looks like this one. The binary math is will be discussed in the previous section, but you know that you will have this configuration. The IP address is 10.1.221.101. And if you're going to input this in your packet tracer, the automatic subnet mask would be 255. And also, the first octet of the subnet mask is 255, and that is the network ID, which is 10. The network ID is 10, and this 10 is in class A, and it should be written if you're going to if I'm going to ask you this question in your test. What is the network ID of this IP address? So your answer should be this one. So this is how it's going to be written. So this is the network ID. And if I'm going to ask you what is the host ID. So the host ID for class A IP address, this would be from this one up to this one would be your host ID. So take note, not all of the IP addresses should have the same scenario. This is only valid, this answer is only valid for class A, but in class B, so you will consider the first two octets, that would be your network ID, and the host ID will be this. For your class C, so you're going to have your network ID, this 3, and this is would be your host ID. So later we'll have some few examples of this. So this is another example. What do you think is the class of this IP address? So this is class. So this is class B. So if you're given the following network IP address 172.31.100.6, so the first two octets of the subnet mask would be this one, and your network ID should be 172.31.0.0, and also for your answer should be this. And for your host ID, so the last two. So this would be your host part. Now, we are already using the term contiguous network as before. We use contiguous network, especially in subnet mask, which means that these are the network in which the packet are sent between the pair of subnet that is passing through the subnet of the same network. So meaning if you have contiguous network, meaning in order for you to pair the subnets, you need to have the correct subnet mask. So if you will not have the correct subnet mask, so it meaning you could not be able to connect the computer. At the same time, the packet tracer, if you're going to already to use this subnet mask, so you could not allocate to another IP address if you maximize already the usage of your subnet mask, so you go with another one higher than the previous subnet mask. So next we have, I think, example 3. So this is what type of IP address in your network 1. So this is your IP address for this example is your class C. So what would be your network ID? Given this example, so the answer would be 192.168.14. That would be your network ID, and your host ID would be this one. So, and you could not have a subnet mask as we mentioned earlier because it must be contiguous. So, well, what we mean by contiguous, that you shall not have zero on this side because you need to fill in the necessary items for you to use uh, this octet. So in this example, what is the subnet mask? So as you noticed, when we going to use this IP address on your packet tracer, automatically the contiguous subnet mask would be displayed, would be this one. So automatic na display some packet tracer. But if you're going to allocate a certain value for your IP address, you should have another notation. So later we'll have this notation that is used in IP addressing. So since you have maybe 50% knowledge of your network one, so you need to read all of the lecture notes on lecture 3 because these are important that would be used for your background in IP addressing. And also you need to review your binary conversion and decimal conversion to make it easier for you to convert the values. And now we have this question also related to your subject, to your topic. What is logical AND? Logical AND is a term that when we say in our logic that if you have 0 and 0, the computer will have an output of 0. And if you have 0 and 1, so you will have 0. And if you have 1 and 0, so you have 0. And if you have 1 and 1, so you have logic 1. And this make it true. So if you have an output of 1 and in your input A and in your input B, 1, so you'll have 1 in your output. So this makes the statement true. If you don't have, if this is false and false, so you'll have false. If it is false and true, so you'll have still false. So there are only 4 possible results when you combine 2 binary numbers. So the 3 of these results are 0. And if it is all of the input are true, so you'll have an output. Now, so we are going to have a simple calculation of your subnet mask. So in this example, we're going to use class B. So what is the class B? So this class B is 172.31.100.6. So you have this as your given IP address. And automatically, if you have this IP address, so you will have your subnet mask. Your subnet mask, when you are referring to class B, would be on the first 2 octets. So this conversion is being already shown for you to know that 172 is the conversion of this first octet. On the second, you have 31. This is 31. And the third, you have 100. So this is 100 in decimal, but in binary, this is the conversion of 100. This is in decimal, this is in binary. And for number 6, so you have only 1, 2, 4. 4 plus 2, that is 6. Now, if you're going to refer for your subnet mask, so if you have one output on all of your bit numbers, so you have 8 bit. All of it will be in ones value. And how do you perform the necessary binary math on this? So you will use A and D to check your network ID to compare the values. So if you have 0 and 0, that would be 0. 1 and 0, that is 0. 1 and 0, that is 0. And until you reach all of these, so since there is no one item on your subnet mask, that makes it going to uh, make it true. So all of this will be 0. And when you go to your second octet, this would make the difference if there is. So as you mentioned, 1 and 1 would be 1. So what you're going to do, you're just going to copy the first octet and the second octet, and you have this. So this is another way to determine your network ID using the logic and operation. But looking at it, so it would be easier. Now, we have another example. So this is an example of what if we have a different subnet mask. Now, with this logic add will be useful if you does have a different subnet mask. So when you have this example, and when you're going to compare the values, so first convert 5 into binary. So this is the conversion. 67 is the version, is this one, and this is 172, and this 16. Now you have 192, and you're just going to copy 255. All of it will be 8-bit, 8-bit, and this would be 8-bit, but you only have 2 1s on the 8-bit, and this would result into 64, and your network ID would be uh, this one. Okay, so this is the answer for your network ID if you have a different value for your subnet mask. As we mentioned earlier, so it depends on your subnet mask. Now, if you have the subnet mask, so you will have a different IP address, network ID. Now, in this example, you have a different subnet mask, so the network ID would be also different. Okay, so any questions on this? So straightforward, and it's, I think, easy. Now, earlier you mentioned that we have this output. So the remaining bits address that are part of the network ID are the host ID. So in this case, so the host ID is what? So we are referring to this one. So how do we get 3.5 host ID? So I will get a pen. So since in our answer would be on this side, so so we are referring to even numbers usually for your network ID. So if you have this IP address, so you're just going to subtract this value. So 64, 67.5, since we have what type of IP address we have. When you see 172.31 is normally class B. So meaning the first octet are the network ID, but on this example, the first octet it would be the until 64. So this is your network ID, but your host ID now, when you subtract 67.5, so this becomes 3.5. This is your host ID. This is coming from your IP address. That is 67.5. This is true only if you have IP address that you need to compute for your network ID. But most of the time, so we have even network ID being used, so that it's going to be easier. So this is your network ID, and this would be your host ID. So any questions on the example, on the add? So no questions. So now, how do we convert binary to decimal? So normally, if you want to convert it easier, so I suggest you to have a table for you to use, so that it's going to be easier. At the same time, you try also to practice at home how to convert these values, so that when a question arrive in the test, it would be easier. Now, converting decimal to binary is one way to convert from this decimal to binary that is in table 1. By using this table, so this is your least significant bit, your LSB, and your most significant bit, MSB, on this side. So take note, in IP address, how many bits are we going to use? So you have to use 8 bits. So this is 1, 2, 3, 4, 5, 6, 7, 8. And take note, you always start your count from 0. So 2 raised to the 0 is 1. And 2 raised to 1 is 2. So if this is the value, 2 raised to the 2 is 4, 2 raised to the 3 is 8, 2 to the 4th is 16, and 2 to the 5th is 32, and 2 to the 6th is 64, and 2 to the 7 is 128. So this is like your test number. Now, if you're going to enable this value, so what would be the result for this? What would be the result of the binary? So in the binary, now we have 1, 1, 1, 1, 1, 0, 1. So what is the binary value? If you have this value, 1, 1, 1, 1, 1, 1, 1, 0, 1, binary, so your value would be what? 1, 2. So you have 1, 2, 5, because you subtract from what? You subtract 2. So this would be your value. And take note, you will have this value uh, in the value to the 7. So you start from 0 to 128. So this is the maximum value for this number of bits. So you have 8 bit. value. Now, on the other hand, if you're going to convert to binary to decimal, we use also the conversion table. How? So if you're given this binary value 110 10011, so what you're going to do? So first, you're going to plug in the values, and you have this is 1, this is 2, this is what's the value of 16? So 16. So you have this is 0. So 64. So your result would be this is 1 to 8. So you're going to add all of this and you'll have your decimal. So this is 1 to 8, and this is 16, 192. 192 plus 16, that is your value. So 192 plus 16, so you have 2, 6, 8, 92 plus 16, so now you have 216. Okay. Okay, next you have plus, you will add 3. So what is the result if you add this? So you have 192, and you will add this 3. This would be 19. So if you're going to plug in 19, so you have this one, and you have 2, and you have 2 to 1. So the result of the binary is 2 to 1. So this is the result for your, as an example. So that's how you convert from decimal to binary using the table. Now, how do we, I think I'm going to demonstrate this. Okay, so we will have this example. So first, if you have your computer, go to your network and internet. So we have, okay, so example, you go to your this control panel. So you're going to network and internet, and what will happen is you're going to check your network status and task. Is it displayed? Okay, is it okay? It's clear. And after this, you're going to check your connections, and try to check. Okay, when you have your connection, so what you're going to do is to have your properties. You go to properties. Did you click? You need to click your Wi-Fi status connections. You're going to click Wi-Fi. See, disconnect. So this one. So you have this, and you need to click properties. Hoping the pop-up will appear. Okay, there is pop-up, and you will have to type this, and Take note if you type 10 dot, so this is automatically generated. Now if we change that 168.1.1, so we, okay, we go back again and yeah, as you see, if you press tab to the next, it is automatically generated. This means this is 0, and we use again. So that is class B. So this is how you're going to check your IP address. So we go back now to our PowerPoint, I think. Oh, that's how easy to identify your IP address and to configure also. Okay. So any question on this? So now we now go back to the lecture because we don't know what are these IP address. So first we need to identify what are the classes of IP address that we have. So we have the fourth generation IP address. So we call it the Internet Protocol. And only IP addresses in A, B, and C are to be assigned in the network device or host. And although you need to have your classless interdomain routing. This is the class system basis for determining which part of the IP address is the network ID and which part is the host ID. So we call it CIDR notation. Later, we'll have this example on the CIDR notation. And take note, the first octet of the order of the address denotes its first class. So what you will have is the Internet Protocol version routing most internet traffic, but its address supply now is going to be depleted because we are using now Internet version 6 because we have only a limited amount of IP address in version 4. So an IP address version 4 may look like the sequence of numbers like 84.2.36.222, 220. In this format, it appears that there is one element in appear in 2 to the 8 versions. This numeric system distinguish among 2 to the 32 IP addresses. So this type of addressing is absolutely satisfactory, but because of the World Wide Web unexpected growth, so the network professionals are facing more and more issues. And one of the problems is that the amount of distributed IP address is not enough. So also the second reason is that version 4 IP address are being distributed according to preliminary estimation. There shall be within a short period of time. So another problem is that the protocol does not support mobility and it's not possible to support encryption that is built in into the protocol. And this was the reason why the network professional tried to establish. Nowadays, there's an existing IP address version 6 to solve the issues of version 4. So because the implementation of version 6 is so complicated and it has going to be a different, having a different numeric system, in such cases, we still use version 4 to handle small bit of data. And both of them cannot operate concurrently. So version 6 operate differently to version 4. And in such cases, the next version after version 4, instead of 32-bit used by version 4 addressing, because how many dot notation we have? So we have first octet, second octet, third octet, and fourth octet. So 8 times 4, that is 32. So we use 32 bits, all of the maximum value in version 4, while version 6 use 1 to 8 bits for the same purpose. So now in version 6, it's possible to provide 2 to the 128 addresses, which came along to provide a long-term solution for the depletion of IP address in version 4. In this example, so this is an example of a IP version 6. So they are not using binary to decimal, but you can use decimal to hexadecimal value. So the 8 groups of 4 hexadecimal digits are separated with colons, where each element stands for 16 bits. Okay, so each this is 16-bit as compared to your IP address, which each is in 8-bit. So as a result, all devices connected to the network will have public globally unique IP addresses, and it can be sent over the internet, which renders the network address translation service used by the firewalls and routers. So which is unnecessary in IP version 4 networks. So this is needed in a way that a central element of each subset, for example, a router would get only one unique IP version for IP address. Then, with a built-in function, it would be give a unique identification to each endpoint of the subnet, which, however, won't be unique on the internet. Now, if you want to check your IP address version 6, so you'll have this web. So you try to check if you have IP address. So this is an example. This is my IP address in the network. So yeah, class B network. And they will give you this one. This is your hexadecimal value for your IP address version 6, and this is version 4. So your DNS server is run by your ISP. So in such cases, we have this one. So the value of the first octet class A is from 1 and 1 to 7. So that is class A. So common class A. And this allows 24 bits of address space. So it would allow you more hosts using class A. So you have 16 million hosts per network address for class A. And commonly we use 10.10.0 as your class A. Now for class B, so you have values from 128 to 191. So earlier we have example related to this one, 172. So this is class B, and this one is class A example. So if you have this example, so your network ID would be 172.17, and your host ID would be this one, 11.4. And having 2 octets in the host ID allows you to have 65,000 hosts per network. So class A will have a million of a host and 16 million hosts, and while Class B can occupy about 65,000 hosts, and for Class C, so you have from values from if you type 192, normally this would be Class C, and this would be until 223. Okay, so an IP address will assign on the first three octets ranging from 192 to 223. This is an example of your Class C address, and it's only limited on this small host like 254 hosts per network. There is also Class D, which is reserved for multicasting. This is addressed so that more than one destination can receive it, and application using this feature include video conferencing and streaming media in Class D address, and the first octet is in the range of 224 to 239. And by the way, Class D cannot be used to assign for an IP address to the host computer. Mostly they are used in projector, television. So these are Class D addresses for multicasting. And we have also Class E address. These are from 240 to 255. That is in the first octet. The range address is reserved for experimental use and can't be used for address assignment. So these are the categories of your IP address. So we have Class A, values from 1 to 7. Class B, values from 128 to 192. And we have Class C from 192 to 223, and Class D 224 to 239, and Class E that is for 240 and 255. So as a summary, so this would be your IP address for the summary. So as the number of your host bit increases, so you will have also a number of hosts. So if your host bit is decreasing, so you will have only few number of hosts, and you will have a number of a network ID that you're going to use is going also higher when you're having a few number of hosts. And the default subnet mask usually are these following: Class A, Class B, Class C. Now, take note of this calculation. So the host, to get the number of hosts, so you need to have 2 to the n minus 2, and n is the number of bits in the host ID being able to assign to its main address. So we have this private ID. So normally, private IP address. So if you want to create a private network that is not going to access outside your connection, your ISP, so you have your own private network inside. So you could have one Class A network address that would cater for a large number of hosts. For Class B, you could have a 16 Class B network address. And for Class C, you have a 256 Class C network address. And these addresses range cannot be routed across the internet, which why any organization can use them to assign within their own network. If the access to the internet is necessary, so you will have what we call a network access translation if you want to access outside the network. So private network, you could assign it to your device that would generate a unique IP address. And now we go with the term classless interdomain routing. So this method is used to identify how many ports do you need, how many IP addresses you need. So CIDR notation uses the format. So we have this format, and this is slash notation, that is the number of bits in the subnet mask. So it's expressed in another way, the number of bits in network ID, which is referred to the IP prefix. So given the following, so there's another term for addressing. So we have the automatic private IP addressing, APIPA. So this is used for private addressing, while your dynamic host configuration protocol, DHCP, it's assigned automatically when a computer is configured to receive an IP address through DHCP, but there is no DHCP service available. Now, for example, we have this value. So we have 172 dot with the IP address of this. Now, how do we know that we have 24 bits? How do we know that we have 24 bits? So first, what you're going to do is what? First, you will try to convert. So this one, one. Okay. How many ones do we have? How many ones do we have in this example? Anybody? Hello? How many ones do we have? So eight. Okay. So each address we have eight. So 8 plus 8 plus 8 is equals to what? 24. So you just going to put the answer. So the answer would be the CIDR notation. So the correct CIDR notation is this one. So because you already count the uh, number of your bits. So network ID. So you have this. It doesn't matter whether class A or class B. What is happened? What would be the given? So kung given naman so you just follow that this is the given for this network. Okay. Now we have another example. This one, 10.25.106.12, and you have a subnet mask of 255.255.240. Now, how do you compute for your subnet mask? Again, we have the same. So you have 8 ones for the first octet, and you have second octet, and you have another 255. So 255, so you will have, how do you generate 240? 192 plus, how do you generate 240? So you have, So you have 1, 2, 0, 0, 0, 0, and you have 0. So you have this as your octet, and you have 16. Okay, so take note, you have 8 plus 8, 16 plus 4, you have 20. So this is your third octet. So if you going to generate to 40, so you add 1 to 8 plus 60, 64 plus 32 plus 16. So you have 240. And take note, you have 8 bits host ID. This is your 8-bit because this is your host ID. And now the number of zeros is always the number of your host ID. And this one, zeros, so you count your zeros here. 4 plus 8, you have 12. So this is your 12 bits host ID. So is it difficult or not? Now the answer for this is this one. This is how you get your CIDR notation, your classless interdomain routing notation, based on a simple conversion from decimal to binary and binary to decimal. Any questions on this? Okay, so I think we don't have anything for here. Okay, so I think we will just stop here for a while and we continue subnetting. We are on the 70th slide, so I think we will have it tomorrow, and we'll end our lecture 3 tomorrow because we have few slides, but these few slides require you to be attentive because this requires calculations. So there's a lot of calculation tomorrow, but now for a while, you need first to know how to convert to check which is the network ID, which is the host ID, and you need to also to identify the correct notation for this. Given this example, you know how to write your CIDR notation because this would be used in subnetting. Okay, so I think we will stop here. And so any more questions regarding our topic, which came along for already for 3 meetings already? So any questions? That is why I told you this lecture 3 is very important. So you could not just stop discussing this and take a rest.